Hello students, I am Dr. Sunita Tandon from RR College Alwar. We are studying Physical Chemistry's special paper Chemical Dynamics for M.SC final students. We have studied about NOx reaction mechanism, ClOx reaction mechanism or kinetics of those reactions. Then we have studied methane oxidation and then low temperature methane oxidation, and last turn we have studied the autocatalyzed reaction, kinetics of autocatalyzed reaction. Today we are going to start oscillatory reactions, autocatalysis and oscillatory reactions. An autocatalysis, the appearance of one of the product act as catalyst in the same or coupled reaction. In case of autocatalysis, last lecture, I have told you the autocatalyzed reactions are those in which one of the reactant acts as a catalyst itself, or the product which formed acts as a catalyst, or any intermediate form acts as a catalyst. So such type of reactions are known as autocatalytic reactions, and in that case we have studied the reaction of oxalic acid with KMnO4. When oxalic acid react with KMnO4, Mn2 ions are formed and carbon dioxide is given out. The balanced equation is given in the last lecture. In this case, Mn2 acts as a catalyst. It is a product of reaction and it acts as a reactant catalyst. Reaction between paramagnet and oxalic acid is an autocatalysis because Mn2 as a product starts acting as a catalyst. Consider a reaction between A plus B changing into 2B with a rate constant of K. Autocatalytic reaction in which K is the rate constant. Rate equation for above reaction is given as rate is equal to d by dt of A minus d by dt of A is equal to K into concentration of A into concentration of B according to law of mass action. This is equation number 1. Let A0 be the initial concentration of A or at a time 0 time. When the reaction is not started, the initial concentration of A is A0. AT is the concentration of A at any time after some time when the reaction has been proceeded. And BT is the concentration of time at any time when the reaction started and B is formed. And B0 is the initial concentration of B when the time is 0 time or when the reaction has not been started. Then let A0 minus AT is equal to BT0 minus B0. इक्वेशन नंबर 2. A0 इनिशियल कंसंट्रेशन है. जब इसमें से कुछ समय के बाद AT कंज्यूम हो गया तो BT बन जाएगा. AT कंज्यूम हुआ तो BT बन जाएगा, और BT कंज्यूम बन गया B से रिएक्ट करके, तो जो इनिशियल कंसंट्रेशन थी B0 वो कम हो जाएगी एंड देयरफॉर BT माइनस B0. फर्दर लेट X बी अ प्रोग्रेसिव वेरिएबल like X is equal to AT at time t, equation number 3. The concentration of B at any time t can be calculated from the relationship from equation 2. Just see the equation 2, we can write BT is equal to A0 plus B0 plus B0 minus AT. Okay, this is equation number 4 we get from equation number 2. Now from equation 3, AT is equal to X. In the equation number 3 we have seen that X is equal to AT. Now substituting AT is equal to X in this equation, we can write A0 plus B0 minus X is equal to equation number 5. All the values of A and B in terms of X in equation 1 from 5, we get minus dx upon dt is equal to kx A0 plus B0 minus X, where from equation 3 A is equal to X, B is equal to A0 plus B0 minus X. This equation on integration after separation of variables dx upon A0 plus B0 in bracket x minus x square integrated is equal to minus k dt. When this equation is integrated, Then after solution we get a equation 1 upon A0 plus B0 ln A0 upon B0 into B upon A, and this is equal to minus KT. Since we are measuring in terms of B, then omit A0 A terms and transformation be ln B upon B0 is equal to KT A0 plus B0. And from this we can calculate B is equal to B0 e raised to power minus KT into A0 plus B0. Similarly, B is equal to B0 A0 plus B0 upon A0 plus B0 e raised to power minus KT A0 plus B0. In if ln, that is log to the base e ln A0 upon B0 is approximately equal to B upon A, that is divided by B0, then B is equal to A0 plus B0 upon 1 plus A0 plus B0 raised to e raised to power minus KT A0 plus B0. Note that at t tends to 0, note that at time t tends to 0, B is equal to B0. If B0 is equal to 0, then the only solution that is B is equal to 0 for all values of t. Secondly, if B0 is greater than 0, that is positive, is initially present, then there is a slow increase. This is increase, arrow बन रखा है और ऐसे लिखा है increase in the concentration of B with which is called as induction period. Smaller is B0, longer is induction period. The rate of rise in concentration of B then increases autocatalytic effect, goes through an inflection point. Maximum is at dB upon dt at some time t, and levels off at the value of B is equal to A0 plus B0 at long terms. Therefore, if B0 is greater than 0, then a plot of B versus T, it comes out to be B on y-axis and T on x-axis. We get a curve which shows induction period of some time and then rises, and at particular point, inflection point, we can see. This S-shaped curve is associated B within rising subpopulation. Thus, thus one or more autolytic steps in a complex chemical mechanism can lead to the phenomenon K upon A is chemical oscillation. The first chemical reaction exhibiting oscillation was discovered by a Russian scientist Bezov and was later justified by Zaborodsky. This reaction is called as BZ reaction. As the pronunciation of this Russian name is quite difficult, Belozov-Zabotinsky. This is famously known as BZ reaction, and in further studies we study the BZ reaction, we will call it as a BZ reaction. Hope you will understand about the oscillatory reaction, and next BZ reaction we will study on next time. Thank you, students.